All right, I thought I'd run through this Mach 4 test. This is number 4, the very first problem off there. So it tells us the function f above it, that's graphed up there is continuous from -4 to 4. We have those 2 line segments and then 3 parabolas. It does tell us there's a horizontal tangent at x equals a -1/2, so right there. At x equals a positive half right there, and at x equals 5/2, which is right there. We know that this function right here is defined by f of x right there from 1 to 4. Areas A and B bounded by f and the x-axis are 3 and 5 respectively. So A is 3 and B is 5. Let g be the function defined by g of x equals the integral from -4 to x ft dt. Find g of 0 and g of 4. So I'm going to do this part up here above. So I'm going to start with g0. So when you do this, just plug the numbers in. So g0, like we're plugging them in here, is equal to the integral from -4 to 0 of f of t dt. Okay, so really that means area under the curve from -4 to 0. So I already know this area A. I need to find the area of this triangle right here. We know the base is 3 and the height is 3. So if I do 1/2 the base times the height, that's 1/2 3 times 3. So this area comes out to be 9/2. Now be careful, that area A is below, so we're going to subtract that. So g of 0 is going to equal 9/2 minus 3. You can leave the answer like that. If you simplify it, right, that comes out to be 9/2 minus 6/2, so 3/2. Okay, so that's what g of 0 is equal to. I'm going to erase this just to save space. And when you're working on your test, we talked about this, but make sure you're going to be doing it on your own paper. Make sure you have full pages. You can do up to 5 pages per question. So really you could do a page per part on this number 4. And you'll see on a couple of these problems, you'll probably need all of that. Okay, g of 4 is a little bit tougher, but that was worth 1 point. So if you got that answer, you got 1 point. G of 4 is a little bit tougher. We're finding the integral from -4 to 4 of f of t. Well, I already know the area from -4 to 0. So I'm going to break that integral up. I'm going to say g of 4 excuse me, is equal to the integral from -4 to 0 plus the integral from 0 to 1, because I know that's area B right there, and I know what it's equal to, plus the integral from, and then this last part, right, this last part we know is defined by this function down here. So we could say it's the integral of -x squared plus 5x minus 4 dx. So that's from 1 to 4. The nice thing about this problem is we know a lot of it, right? I'm going to come over here. G of 4 then is equal to, it's 3/2, right, that part, from -4 to 0. From 0 to 1 is 5. To find the rest of it, though, I've got to evaluate this integral over here. So I'm going to evaluate that. So it's plus, I'm going to integrate that. It'd be -x cubed over 3 plus 5x squared over 2 minus 4x. And we got to evaluate that from 1 to 4. Okay, so let's plug all that in there. I end up with 3/4. Ooh, that should not be 3/4. Glad I caught myself. That should have been 3/2, right? That's what we had up above. So 3/2 plus 5. Okay, plug your 4 in. That would be minus 64 over 3 plus, plug 4 in there. That would be 16 times 5, I believe, is 80 over 2 plus, or minus, plug 4 in there. 4 times 4 is 16. Minus, plug 1 in. So if I'm minusing a -1/3, it changed to positive 1/3. Plug 1 in there. So remember, we're subtracting all this. So it's minus 5/2. And it'd be a minus 4. So it'd be a plus 4. And we really don't have to go past there. You can, if we need it later on, we can go back and plug in the calculator. But really, that's good. Hey, the breakdown on points for this problem is getting g of 0 up above gave you 1 point. Finding the integral of 1 over 4 gave you, so doing this part right here, you know, this part, let me outline it in a different color. So doing this part right here, you know, all the way down through here, finding that part right there got you another point. Actually, just doing this part got you 1 point. Finding the antiderivative, this got you another point, and then evaluating it got the third point. So this was 4 out of the 9 points right there. Like you can do this part A of this question, and you've already, you know, on this question you scored high enough to probably get a 3-4 on the AP scoring, you know, on the test without even having to finish the other sections of it. By the way, the answer comes out to be 11, it looks like. Okay, let's look at part B next. So if we go down to part B, it says find the absolute minimum of g on the closed interval from -4 to 4. Okay, remember to find the absolute minimum, you have to consider the endpoints. So we have to consider the endpoints. And we also have to consider the relative minimums. So let's look through there and figure out the endpoints and the relative minimums. Now remember this, one thing to be careful with here is, right here, if g of x equals the integral from -4 to x of f of t, that means that g primed of x, right? If I take the derivative of this side, it's the derivative of an integral. That's the second fundamental theorem of calculus. You can just plug in the x in there. So this graph up above, f of x, is the derivative of g of x. So just keep that in mind. In fact, I think it's helpful to come up here and next to this graph of f, we can put right there, it's also the graph of the derivative. So if you're looking for relative mins, you're looking for the y values on this graph, and you're trying to find out when it goes from a negative to a positive. So right here, the y values are all positive. That means the slope has to be positive of g. Okay, now it changes to negative. Now it changes to positive, and then it stays positive. So the only time it changes from negative to positive is at 0. So that's the relative min. So I've got to consider those my endpoints, and I've got to consider what is g of -4. That's an endpoint. G of 0, and the other endpoint is going to be g of 4. That one's we're not going to have to worry about that. If you think about this problem for a second, as long as you have positive area, g is getting bigger. So after g of 0, you can see all the area across here is all positive. So g of 4 is going to be bigger than g of 0. It's not going to be g of 0. It's not going to be an absolute minimum. So it's either got to be g of -4 or g of 0 as you look across there. So we just need to compare those. So look at our problem here. You know, if I want to find g of -4, I would go the integral from -4 to -4 of ft dt. Well, hey, whenever those are the same, -4 to -4, that means it equals 0. So g of -4 is equal to 0. We already know what g of 0 is, right? We found that up above. G of 0 is equal to 3/2. So we want the absolute minimum, the lowest it goes to. It would have to be g of -4, which is equal to 0. So we would say, find the absolute minimum would be g of -4 is equal to 0. Hey, the way you show work on that is you would just say, you know, to find a relative min, check the endpoints, check the relative min. G of 4 is greater than g of 0 and g of -4 because of the positive area under the curve between 0 and 4. Then just say, so I'm comparing g of -4, g of 0. G of -4 is 0, g of 0 is 3/2. Therefore, the relative min is g of 0. That one was worth 3 points. You got 1 point. I just want to point this out. They give you a point just for putting this. Like, this is important. You need to include that as part of your assignment. And the next thing is you have to identify these two as candidates. You have to identify that you're looking at -4 and 0, and then the actual answer or justification. Okay, the last one, C, find the intervals in which the graph of G is concave down. Give a reason for your graph. So again, this is the derivative of G. That, excuse me, that means that we're going to look at the slope of it to find the concavity, because that would be the second derivative. So look at the slope. Right here, the slope goes from a positive to a negative. So if you think of our f double prime number line, we know at -2, there's a change in slope. Then at a half, -1/2, a half, and at 5/2, that's where all the slope changes. So from here, that section right there, the slope's positive. From there all the way down to there, the slope is negative. From there up to a positive 1/2, it's positive. From there, it's negative. But then, so that's to, the slope is negative. Oh, we should have put 1 in here. Sorry. So from 1/2 to 1, the slope is negative. From 1 to 5/2, the slope is positive. And then after that, the slope is negative. So the question was asking, find all the intervals in which G is concave down. Give a reason for your answer. So we're just looking for when it's concave down. So as I look across there, it's going to be from -2 to -1/2, right? It's concave down. And then the other section is going to be a 1/2 to 1, right there, it's concave down. And then 5/2 to infinity. And my reason, it wants a justification. So what I would say is from -2 to -1/2, it's concave down because the slope of f is negative. From 1/2 to 1, it's concave down because the slope is negative. From 5/2 to 4, it's concave down because the slope is negative. So there's 2 more questions right there. This question wasn't bad. I mean, there was some algebra involved there and a little bit of work, but it wasn't terrible. The last question, if you noticed, that was kind of a beast, and we'll get to that. Okay, this one, we didn't do the whole problem. I just picked a couple parts of it because it all doesn't, the other parts were stuff that we are no longer covering. But it says, Brendan and Chloe ride their bikes for 4 hours along a flat, straight road. Brendan's velocity in miles per hour at time t is given by the differential function b for between 0 and 4. Values of b of t for selected times t are given in the table. Chloe's velocity in miles per hour at time t hours is given by the piecewise function. So we've got that first function defined by the table. We've got the second function that's defined by that piecewise function. So part B says, at time equals 3, is Chloe's speed increasing or decreasing? Give a reason. So just remember, find the derivative, c prime of t. If it's at time equals 3, we only care about this part of the function. So I'm going to find the derivative of that part of the function. That would be -3 minus 2t. And I'm going to put off the side for when t is between there. So let's find, excuse me, let's find out what her speed was at that point. So if I plug 3 in, c prime of 3 equals -3 minus 6. So it's equal to -9. This way you have to be careful. A lot of times we see a negative acceleration, so we think the speed is increasing or decreasing. But remember, you have to compare the velocity and the acceleration. If they have the same sign, if they're both positive, that means they're speeding up. Or if they're both negative, it means they're speeding up. If they're going in opposite directions, it means they're slowing down. So that means I need to find the second derivative to the acceleration. So I'm going to go at c double prime of t is equal to, that would just be -2. So that means there's always a negative acceleration. So at c prime of 3, c double prime of 3, I have negative velocity and negative acceleration, which means they're actually speeding up. On this one, let me grab the scoring guide here, and we'll go through the points. So you get 1 point for showing both the first and second derivative are negative, and then you get another point for your reason. And the reason, all you need to say is because the signs are the same or because they're both negative, that means her speed is increasing, okay, when you find that. Okay, part C. Oops. Part C says, is there a time from 0 to 4 at which Brandon's acceleration is equal to 2.5 miles per hour, and it wants us to justify our answer. So it's talking about his acceleration. So what I would do is I would find the average acceleration. So if I go up there, I can use the velocity to find the average acceleration. We're going from 0 to 4. So I'm going to use these 2 points, 0, 1, and 4, 11, to find the average velocity. So I'm going to go 11 minus 1 over 4 minus 0. I just use my 2 points, 1, 0, and 0, 1, and 4, 11. When I do that, I end up getting 10 fourths, which actually comes out to be 2.5. So whoops, sorry, I should slide this all down here, shouldn't I? So there's my average acceleration, is 2.5 miles per hour. The question is there a time between there? Well, if you go up above, it tells us something. It tells us that it's a differentiable function, b is. That means it's continuous. So I'm not going to write this down, but my justification, my reasoning would be, I know the function is continuous because it's differentiable, because it's continuous by the mean value theorem. You know, if the average is 2.5, there has to be some point between 0 and 4 where the acceleration has to equal 2.5. All right, D. I thought D was a tricky one, and I justified it, and I stand by my answer. I think it's an answer. It's a little bit different than the way the AP answer key does it. But it says, anyway, the question says if there's a time t between 0 and 2 at which Brandon's velocity is equal to Chloe's velocity, justify your answer. So what I said was, we know they're both continuous functions. If you read up above, it says they're both differentiable. They're both continuous. Maybe, let's see, does it tell us actually C is continuous? So maybe we should check and make sure C is actually continuous. They transition it to, so maybe we should make sure if I plug 2 into the first one, I get 2 e to the 4 minus 2. Let's see. So, 4 minus 4. So that's 0, e to the 0, 0. So I get 2 when I plug it in there. When I plug 2 into there, I get 12 minus 6 minus 4. That comes out to be 2 also. So the piecewise function meets. So it is a continuous function. So they're both continuous functions. Okay, and we'd make a note of that. And then we know that if I plug in, I know b of 0 equals 1. And I know, excuse me, b of 2. So I know that at 0 the velocity is 1. At 2 the velocity is 1.5. When I go for Chloe, I know at 0, if you plug 0 into that function, you get 0 back out. If you plug 2 in, you get 2 back out. So it says, is there a time at which Brandon's velocity is equal to Chloe's velocity? So if you think about it, from 0 to 2, Brandon goes from 1 to 1.5. Chloe goes from 0 to 2. That means they would have to cross somewhere. So the way I describe that is just that because they're both continuous on the interval from 0 to 2, and C of 0 is equal to 0, C of 2 is equal to 2, then by the intermediate value theorems, Chloe's velocity on the interval would include everything between 1 and 1.5, right? It would include everything between here. Therefore, they would have to be equal at some point. So you can look at the way the AP scoring guide does it too. They approach it a little bit different, but I'm pretty confident that I would get full points for that. So that one was worth 2 points, that last question right there. Okay, let's move on to the last one. There's a lot of algebra in this last one. I don't know that the problems, C I thought was kind of difficult, but overall the problems aren't awful, other than there's just lots and lots of algebra, so you have to be really careful not to make mistakes. So we did another question similar to this, where it gives us a curve defined by an equation. It wants us to do implicit differentiation to show that the derivative of this is that. So this is something we should be pretty comfortable with, I hope. Do implicit differentiation. That'd be 4x plus 6y, don't forget the y primed, right, whenever I take the derivative of y, minus, do not forget the product rule here. So minus, and I have 4x y prime plus 4y equals 0. Okay, I'm going to distribute that negative through. I'm going to get the y primes on one side, everything else on the other side. So I'm going to move the 4x and the minus 4y over. So I have 6y y primed minus 4x y primed equals, this would be a minus 4y, so when I move it over, it would be a positive 4y. I'm going to minus the 4x over. We're almost there to factor out the y primed. Divide by that. Okay, reduce that down. So that equals, and that will equal what you have up above, right? 2y minus 2x equals 6y, or 3y minus 2x. So we showed it. So we're good there. B, it says find the slope of the line tangent to the curve at each point on the curve where x is equal to 6. And by the way, if you look back up, you want to notice that you don't have to do part A to do part B. I think part A is actually easier than part B, but you don't have to. So just keep that in mind. If I want to find the slope of the curve when x equals 6, if I want to find the slope of the curve, I can't just have an x value. I have to have the y value. So the trickiest part on this one is I've got to take 6 and plug it back into my original equation to find out what the y value is, and then I can plug them in here. So I'm going to start with that. I'm going to take 6 and plug it in there. So I get 2 times 6 squared plus 3y squared minus 4 times 6 times y equals 36. So this would be what, 72 plus 3y squared minus 24y equals 36. It's a quadratic, so I'm going to move everything to one side. I have 3y squared minus 24y. I'm going to have minus the 36 from the 72. Okay, I've got to solve that, so I'm going to factor out a 3. So I'd end up with y squared minus 8y plus 12. Okay, factor that. That would be y minus 2, y minus 6. So I end up with two y values, 2 and 6. So my 2 points I'm going to plug in is when x is 6, y could be 2. When x is 6, y could be 6. We want to find the slope of the line that's tangent at when x equals 6. So I want to find the slope of the line at those 2 points. The rest is the easy part. That's the hard part, is finding those 2 points. So I'm going to say dy dx, and just some notation things. If you want to show you're plugging in 6,2, you can just do that. Just put a 6,2 next to it. So I get 2 times 6 minus 2 times 2 over 3 times 2. I feel like I did something wrong there. Yep, I did. Let's try that again. Sorry. So I'm plugging 6 in for x and 2 in for y. So it'd be 2 times 2 minus 2 times 6 all over 3 times 2 minus 2 times 6. And I don't have to go any further. Now, you can, but that's my answer. And then do the same thing for my other point, which is 6, 6. So it's going to be exactly the same thing as plugging 6's in for x and y. Okay, there's my 2 answers. If you actually work it out, let's see, I'll have to look here. It comes out to be, what, 4/3 and 0. Okay, that's what your 2 answers should be. But you're fine leaving it like that. Like, you don't need to go any further from there. That one, let's see, this is part B. That one was just a point for each. 1 point for one, 1 point for the other. Up above, you had to do implicit differentiation. That step got you once, getting to here got you 1 step, and then doing the rest of it and verifying it got you not 1 step, but 1 point. They got you the other point, so 2 points total. Okay, C. I thought C was the trickiest one. It says, find the positive values of x, which the curve has a vertical tangent line. That part wasn't bad, right? To have a vertical tangent line, we know that the bottom part, the denominator, has to be undefined. So we know that 3y minus 2x has to equal 0. The challenge is, the challenge here is that we have both x's and y's in there. So there are lots of points that would work in there, but to be a vertical tangent line of the curve, that has to work in here. Like, they have to be points that also work in here. So what you're going to do is you're going to take that equation, the 2x squared plus 3y squared minus 4xy equals 36. You're going to take that equation, you have to solve it like a system of equations. I've got to find out what points on this line that would make that 0 would also be on here. So you're solving a system. So what I would do is solve for x on here. At least I think so. You could solve for either one, but I think I would solve for x. So let me check let me make sure I do it the same way as my key. So actually I solve for y, sorry. So I'm going to do it the same way as I did on my key, but you could solve for x also. So I have minus the 3y over negative 2x equals negative 3y, divide by negative 2. Sorry, I'm solving for y, so divide by negative 3. So y is equal to 2/3 x. Now I have to take that in. Everywhere there's a y up here, I have to plug that in. So now I have 2x squared plus 3 times 2/3 x squared minus 4x times 2/3 x. So now we get this nasty equation I got to solve. It actually ends up being okay because they're all x squareds, but still not a lot of fun. This would be 2x squared plus 2/3 squared is 4/9 times 3 is 4/3. So that works out to be 4/3 x squared minus, this be x squared, 4 times 2/3 would be 8/3. Okay, now we can add all those together. If I make this into 6/3, same as 2 right now, I can add it all up. So that would be, what, 6 plus 4 is 10, minus 8 is 2. So I end up with 2/3 x squared. So I'm running out of room here. I'm going to come over here, all the way over here. So 2/3 x squared equals 36. So now times by 3 and divide by 2, so times by 3/2. Get rid of that. So x squared equals, you can plug that in a calculator, but I think it's 54. Take the square root. All right, and this says find the positive, and it's a good thing, that's probably why I solve for x, because it does say find the values of x. So if we'd solve for y, I would have had to plug it back in to find x. So it says find the positive values for x in which the curve has a vertical tangent line. So it's going to have a vertical tangent line at a positive square root of 54 and a negative square root of 54. It just wants the positive value. So the actual answer itself would be the square root of 54. So all of that, by the way, all of that only gives you 2 points. But something I want to point out, this is really important, is this. Just doing that step right there, just that step right there, which was really easy, that right there got you half credit on that problem. That got you a point. So that's the importance of showing, even if you're not sure, even if you're going to screw up somewhere along the way, because it's a long, nasty problem like that one, you can still get your point right there by doing that. Okay, let's do this part D. It says let x and y be functions of t that are related by that equation. At time t equals 1, the value of x equals 2, and the value of y equals negative 2. And the value of dy dt is 4. Find the value of dx dt. So it's kind of confusing the way it's worded, but when you see this, I hope you recognize related rates. We hadn't done a lot of related rates, so I tried to find one that had one on there. The nice thing about it is we already have the equation, right? That equation ties the x's and the y's together. So we just need to connect the dy dt, which we know what that is, right? Dy dt equals 4 when x equals 2 and y equals negative 2. So we've got all that information. I just want to find this one over here, right? I'm trying to find out what is dx dt. Now, normally, a lot of times on related rates, you have to come up with the equation yourself. This one, the equation is already given to us, which is nice. I just have to take the derivative of this, but you just got to be careful. Remember, if you're doing related rates, you're taking the derivative with respect to time. So every time you take the derivative on related rates problem, you have to include the dx dt or the dy dt. Okay, so let's go ahead and do that. If I take the derivative, it'd be 2x squared, it'd be 4x, and you got to include that dx dt. Plus derivative of 3y squared would be 6y dy dt minus, and make sure you do the product rule here. So minus 4x dy dt plus 4y dx dt equals 0. Okay, now from here on out, we're just plugging everything in. So I know 4 times x equals 2. I don't know dx dt, I'm trying to find that. Plus 6 times y, y is negative 2. And dy dt is 4. Minus, I'm going to carry that negative 3, so it's minus 4 times 2 times dy dt, which is 4. And then carry it through again, it would be minus 4 times negative 2 times dx dt equals 0. Okay, now it's just a matter of working out this equation. Right, this is 8 dx dt. 6 times negative 2 times 4 would be what, negative 48. Times those together. 4 times 2 is 8, times 4 is 32. Times those together. So now I can add the dx dt's together. That'd be 16 dx dt. I'm going to move those two both over, the minus 48 and the minus 32 over the other side. So it'd be plus 48 plus 32, 80. Divide by 16. So dx dt is equal to 5. Let's see if there's any label or anything that's necessary there. It says, it doesn't give us, it says the value of dy dt is 4. So we don't really need any kind of label here. Just dx dt is equal to 5 would be our solution. Hey, the breakdown on scoring on that, this one was worth 3 points. You had to, like, just taking this first step and finding the derivative got you, actually, just doing the product rule correctly right here, you know, for that, go back up. Just doing the product rule on this, that got you 1 point. Taking the derivative with respect to time got you another point. And then finding the answer got you the final thing. So you can kind of see how that all broke down. Hey, key thing I want to show here is make sure you try every part on every question. And make sure you show every little bit of work you can, especially the simple stuff. Like the one that really stood out to me is right up here is, this is a super hard question. A lot of us probably wouldn't have got this number C all the way correct. There's just so many places to make mistakes. Sorry, C right here. But all of us can do this part right here, right? We know if it has a vertical tangent, the denominator has to equal 0. That gets you a point right there. All of us know the product rule right here. That gets you a point. I think we can take, there's a lot of stuff you can do out here that even if, with all that algebra, there's easy places to make mistakes, we can show our steps and we can get points. So, all right, keep working hard. Over the weekend, you can, if you have time on your hands, go back and look at those review AP videos. They would be great for you. And then we'll talk more about what we're going to do on Monday. I'll get you an announcement out over the weekend. Thanks, guys.